Welcome back after a long hiatus to SUMURI's Forensics Simplified podcast. I'm Steve Whalen, co-founder of SUMURI and Chief Product Officer. And with me, I have today...
I'm John Day. I'm the Senior Manager of the Software Department here at SUMURI.
Yeah, there's so much to talk about after this long hiatus of actually producing podcasts and stuff. So much has changed. We've been very busy with lots of different things. The first thing that was keeping us busy with the change to the world was opening a new facility and office in the here in Delaware.
Yeah, we moved out of a industrial complex, kind of hiding us in a room with no windows, into a big old historic building. It used to be a peach pit, or a peach factory, excuse me.
Peach pit.
Yeah, sorry. It used to be a peach factory. We kind of renovated it all to make it a nice new forensics building. It's sweet.
Yeah, it's a historical building, so it was nice to actually preserve something instead of tearing it down. Yeah, when we first got in here, it's triple the size of where we were before. Three separate buildings, and the main building is from 1890. And it's actually just all wood. And the first three contractors we had wanted us to rip it down and sell the wood for reclaimed wood. And so we could make millions. But we made a promise to a little sweet old lady that was the previous owner. And we said we wouldn't do that. So we went out of the way and restored and preserved the building. And we actually applied for historical markers. So I hope we get that.
Honestly, I'm just glad that we have windows now. That we have a whole bunch of natural light finally pouring into the building instead of being assaulted by fluorescent lights like the old building.
Yeah, just so you know, is when I got off the road as a trooper, I never saw a window again. And they said if I want a window, they could happily put me back to a patrol car. So you can
get all the windows you want.
Yeah, get all the windows you want. You can change your scenery all the time. Okay. So, so some other things. We're actually located now south of Dover Air Force Base. If you're familiar with Delaware at all, it's not that big, so you can't really miss Dover Air Force Base. Small community town, farm town, and we are the biggest thing in the town right now. So the nickname of the town is actually there's a sign here that says it's the center of the universe. So we thought that was a great place to put our business, just for that reason alone.
Yeah, I think our back shed that we use for storage is actually bigger than the town hall here.
Yeah, it is. It is.
Almost every department. I mean, every department now,
yeah.
Right? So yeah, we're looking for a bunch of new people for the software side of things. We need more people for Tolino, for R&D and some builders too, right?
Yeah. Mm-hmm. Every part of the company, we're growing, even services and such. So if you want to be part of the center of the universe in our company, reach out to us on our hiring at SUMURI.com. But actually, one last thing before we get into today's topic, which is we totally revamped our Mac courses and started teaching it since IASIS of this year. And it went really well. So it's all updated for Mac OS 11, updated for Apple Silicon, and now we've introduced a new certification.
Yeah, so we're doing the CFME, right, is the name of the certification. Yep. And that's going to be basically, we're doing a couple online classes, and then you take an external certification test to get the CFME. I know how much people in forensics love tagging letters onto the back of their email signatures. So it's another set of letters, and honestly, they're great courses. It's a heap of information you're not going to get anywhere else. And it's all, like Steve said, updated. It's all brand new stuff to what's relevant for new things you're seeing now.
And the Mac certification, like our training courses, they're all vendor neutral. So there's no tie-in. We don't even show our software. So even though we have software solutions for this, it's more important for us to actually talk about Mac forensics from the ground up. And that way you can use what you learn and apply it towards any tool or technique, which is kind of what brings us to this next topic, what we want to talk about today, which is why you're doing Mac forensics wrong. And it's this kind of gets people a little bit upset when you walk into a conference and you just look at everybody, pause for a second, and say, you're all wrong. Now I'm the only one that's right. And people kind of like, oh, what kind of person is this? But we've been dealing with this for a long time, and John's kind of new to us. But even in John's new role as managing our software team here in the U.S., he deals with this on a day in and day out basis. You want to talk about some of that?
Yeah, so I've kind of dealt with it from a personal perspective and from working with customers. It's a lot of people are in the same boat that I was when I first got here, and that's that I got all my training on Windows machines. I went to school for forensics, and we learned everything on Windows using FTK and learning things the Windows way, right? And then when you come over to the Mac side, you run into roadblocks right from the jump. Right from imaging, you start having to rethink everything that you knew about forensics. It works completely differently on the Mac side of things.
Yeah, I think it's one of those things where Macs in the old days weren't so popular. It wasn't, you didn't run into a Mac too often. And even nowadays, you may not run into a Mac too often. But when you do run into a Mac, you want to take your existing tools and your existing training and try to apply that towards a Mac. And you just can't anymore. You just can't do it. I've been saying that you can't do Mac forensics the traditional way since I think way back in at least 2006 is when we started doing our first trainings and such, and saying everybody just needs to do it differently. And I've been trying to promote that over the years, and it'll be on my gravestone, my epitaph, as I always say. You need to do a Mac with the Mac, and that's kind of what we want to talk about in this episode, where it is what it is that makes doing Mac forensics different, as to traditional forensics, I want to call it, because you just can't apply it. You're going to lose information. So I actually wrote an email to a customer yesterday. I don't know if you saw it, but it basically said, well, you need to do it this way. Otherwise, you're going to lose data. You're going to lose timestamps. You're going to lose your hair. Your dog's going to run away, and your truck's going to break down. And anything else that you hear in a country song, that's what's going to happen to you if you don't listen to us. So, or at least heed our warnings and know what you're going to miss. So we're not trying to dissuade you from like other tools and techniques. You just got to know what you can get and what you can't get. And there's some major concerns for just being a lemming, I want to call it, and not to just call every Windows examiner or a lemming, but it's just people don't question what it is they do, or unfortunately, a lot of people don't take the time to test and validate.
Yeah, just because you don't see Macs every day doesn't mean you can just treat them like you treat everything else. You see them come in and you have to, it sucks to do it for maybe a couple cases that you see occasionally, have to totally revamp the way you're approaching things, but you have to do it because each case is as important as the last one. You can't mistreat this one just because it's different and more complicated. You have to take these extra precautions, and even just being aware of what to look for is a huge help in being able to tackle the Macs properly. Because even something as simple as knowing that if you're dealing with a Mac, you need to be looking for passwords more diligently on site for doing collection and that kind of stuff can totally change everything about the way you even start your exam.
Yeah, so we have a decision tree for imaging on our website that you're welcome to look at in our resources section. And the very top of it, it asks the questions, do you have the password? Because if the answer is no, then we tell you have a doorstop or a nice Frisbee or something like that. So yeah, it's a password is a key. So I guess we can start with that. So like, why is there a need for a password now?
So if you're looking at any Mac that comes through your doors past 2018, there's a couple that were made in 2018 that don't have it, but most of them in 2018 did. Macs past 2018 are going to have a security chipset in them that will require the password for any kind of imaging that you're doing. And it all comes down to the way the data is set up when the machine's turned off. So it makes physical imaging a lot honestly impossible when you're looking at this new hardware, because you have to kind of decrypt the data as you're going. So if you don't have access to the admin password on that machine, you can't validate and you can't decrypt the data.
And we're talking about the dreaded T2 chip, right?
Yes.
Which is not even an issue anymore because they wrapped that up into the system on chip with Apple Silicon. So the secure enclave is now built into the system on chip in Apple Silicon devices, and you probably won't hear the T2 chipset anymore.
Yeah, unless you're looking at, I guess they're kind of, it's crazy to think that 2018 is old at this point.
Oh,
right?
yeah.
Like it's kind of an outdated computer at this point.
Unless you're still dealing with Intel Macs that are slowly going away, which is another reason why you need. So essentially what John is saying is that since 2018, if you're dealing with any Macs after that, whether it's an Intel with a T2 or a Apple Silicon, all the data is encrypted at rest. So think of it as like your iPhone. So your iPhone, after a certain point, I think it was iPhone 4S, is where you couldn't do physical dumps anymore. That's because all the data is encrypted at rest, and you have to pass it through this secure enclave in order to get the data out logically. And that is the key word right there, getting the data out logically. So let's talk about next the physical versus logical imaging.
Yeah.
When it comes, you want to tackle that one?
Yeah. So essentially, what ends up happening is that looking at the physical disk is kind of pointless, and it's because of what Steve said. The data at rest is going to be completely encrypted, and it's not encrypted with a algorithm, kind of like when you're dealing with file vault or BitLocker, where you could take if you had an older Mac, right, you take a physical image of a file vaulted machine and then you throw it into our tool or another tool that has decryption, and you can decrypt it because it's algorithm based. This is hardware based. So doing the physical imaging, it still has the encryption, but it's tied to the hardware of that machine specifically. You can't drop it onto another machine and decrypt it later. So that forces you into doing logical imaging. And then, there's a whole host of problems that come with logical imaging. You're not getting your unallocated space. You are liable to lose the timestamps that you're the modify access create timestamps. Some of those will end up changing when you're moving it to a new logical container. And it's just kind of it's a different approach that you have to take, because I know a lot of the times you don't want to do logical imaging. You're trying to avoid it as much as possible, but here you can't.
Yeah, I think that's the biggest problem. Because I know this is a podcast, you can't really see John, but he's like 12 years old. He hasn't dealt with these issues like I have over the years, So, but the thing is we're used to, when we're trained, right? We don't want to change the data, and we want to get a physical image. Well, that's one of the biggest hangups that we get with customers on the phone when we're helping them with ITR Lab, is that, like, listen, you're not going to get a physical image anymore. I'm like, but I want one. And I'm like, but you're not getting one. And they're like, but
physical EO1.
Yeah, exactly. Yeah. Physical EO1, which is like, we're just like, we just sigh. Well, we try to put them on mute first, but you're on hold, but now sometimes it just comes out. And so, yeah. So like, if you're still thinking physical images and EO1 images and stuff like that, you're just gotta just either catch up with the times or retire. So that's all I'm going to say. And I've been this long enough to say those words. But and I'm not meant to make any. Sometimes retirement's good. I think about it all the time.
Yeah.
So I wish
not getting away that easy.
Yeah, I know. But the problem is it's what we were trained for so long, and then things do change, and it's going to change even more. So like and not to get on a whole nother subject here, but companies, major computer manufacturers or computing devices like Google, Apple, and Microsoft, they're making their own chipsets now. They control everything. Mm-hmm. The things that you or know as forensics today, 3 years from now, will be totally different, and you will have no choice. That's why I'm saying, if you're not ready or prepared for this, and you're seeing this with Apple, it's just time to get that RV and go traveling.
Yeah, we say this about Apple computers now, but like you said, Microsoft's heading down the same path. For all you know, every machine you're gonna have to just do logical imaging in the future.
Yeah, So just back to that again. What we're talking about is if something's encrypted at rest and you decrypt it, the data is basically coming out logically. And then with Apple, which is, again, it could be a whole nother topic or a video that we can do later on. There's just so many different things. Like, so I always joke around and start out in our classes when I talk about this and say, if you can follow along, then you're okay. If not, it's going to take some time. But essentially, you got a physical disk that has a traditional logical volume that is used to make a physical store, which is a container disk. And that container disk is then broken down into virtual volumes. And those virtual volumes, there's two of them there, which are put together to make your Macintosh HD hard drive that we know and love. But it's not the two that you think of. There's actually another one, a snapshot of the other system volume. And you got to put that together with the data volume. And those together, Mac magically combined using a Mac, gives you the Macintosh HD, and your data comes out logically. So if you didn't understand what I said right there, you just need us. That's all I have to say. You need us. And so we've been working very hard to stay on top of this with our tools, with RECON LAB, RECON ITR. And I hate to say it, you got to be on the Mac. There's two ways of doing this, right? Using a Mac to do a Mac and navigating through what we just said, or using tools that are natively designed on a Mac to handle this, which we are, right? Because there's other tools out there that are seemingly run on a Mac, but they don't come from Macs. They come from Windows. They come from the Linux world, and they have limitations such as timestamps, right? So this leads us back to even thinking about the containers, and that's another big issue that we've been having with customers lately.
Yeah, so we joked about it earlier with I want my physical EO1. A lot of times I talk to people and they'll be like, all right, but our lab uses EO1s. I need it to be an EO1. I need it to be in this format, right? But it's just kind of, if you're taking the correct approach, you kind of can't force things into an EO1 or into other containers that aren't built on the Mac platform and Mac native. So that's kind of why we end up moving more towards sparse images and DMGs and folders when we're looking at logical acquisitions for our tools. It's because if you're doing this the right way, if you're extracting data the correct way to preserve all of your metadata and preserve all your timestamps, you have to work with the Mac as opposed to working against it. And if you're trying to take your Mac commands and jam the data into a container that it doesn't want to play with, it's not going to play nice with an EO1 because nothing that we're using to pull the data out knows how to use an EO1 properly. So you kind of have to force it in there. But when it comes to DMGs and sparse images, all the commands are designed to output to that, and that's why we like to stick to those.
Yeah, so even when you're thinking like, well, why can't we just use an LO1? It's same reasons, right? They're not designed. Nothing. Even go back to the fact that like NTFS or XFAT or FAT32, right? They're all different file systems that you can actually write an image to or logically collect data. There are things built into the file system of the Mac itself, starting with the disk structures and volumes that are there to preserve special metadata that only exist on the Mac. And then if you come off the Mac ecosystem in any shape or form, you're going to lose something or either not get anything. That's the big concern. So what we do, and the approach that we've taken, is that we do everything Apple native. So everything we do from the beginning to end is Apple native. So we know Macs understand Macs, and then we therefore we never have a problem. What everyone else is doing, including other tools that run on a Mac, is reverse engineering. And when you get into reverse engineering, that doesn't mean you're always going to be correct. It doesn't mean you're going to be 100%. But if you're doing Mac on Mac, so Macs understand Mac, you're always 100%. So we took a different approach over the years, and still do, to collect this data. And we could talk about some of those things now, especially the containers. Because one of the things that happens is that we tell people with our solutions for imaging, for example, RECON ITR, we suggest imaging to a DMG. And sometimes if you're dealing with these different file systems or hardware that require logical imaging, so take the Apple Silicon, where you're basically a lot of times just imaging live off the desktop because there's no more target disk mode. If you're wondering about that, that's not really the best solution out there anymore. There is none anymore for Apple Silicon. And then they have something called shared disk, but shared disk and target disk mode now are both throttled by Apple for some strange reason. So that's what we've been finding out. So now a lot of times people are just imaging live off the system itself. But think about this. And I don't understand why this has never been solved before, but when you take a file from one volume to another volume, like another disk or volume, right? You're collecting something logically. Of course, when you add something to the new volume, dates and times are going to change. So what we've done is we've corrected that in our imaging tools. So our tools, RECON ITR, logical image solves that. The process that we use solves that, as long as you're loading it into RECON LAB, which we can talk about later. So ITR is our imaging tool. RECON ITR is our imaging tool for Macs and others. You can do Windows and Linux as well with the drives that we provide to you. And then our full analysis suite is RECON LAB that runs native on a Mac and designed that way. We built everything so that you preserve that data where other solutions lose it. So what we find out that happens is a lot of people are like, well, I just want to use half the product. I just want to buy RECON ITR to get my image and then put it into my favorite, Windows tool or something else. Yeah. But the problem is you're still going to lose that information. So you're doing the first step right, and then you lose information when you put it into the analysis tool. So that's one of the things that we wanted to talk a little bit about here. So containers is really important. Yeah. Right. So it's not as simple as like, well, I'm just going to put it in a DMG. So, because I know my other tools support DMGs. It's not that simple.
Yeah, you might get support for it, but you're not getting optimal support for it. So you're going to get it, you're going to get the data off, but you're going to have a bunch of wrong timestamps. You're not going to be able to extract certain Apple proprietary metadata because you're sitting there on a Windows machine, right? The problem is the Windows that's in between your Apple information and your tool.
To this date, as far as I know, there's no other tools except for RECON LAB that actually integrates the proper extended metadata and timestamps into the interface so you can do the proper analysis of the Mac. I believe we're still the only one. I don't know if it's even possible in other tools because again, we're not reverse engineering. We're basically using a Mac to look at a Mac. So, and then one of the things that's come up recently too is like using a DMG versus sparse image. Like, what's the difference? Yeah. So the difference is this, right? Sparse images are dynamic. They can grow and shrink, right? So they can actually grow in size if necessary, right? And then that's native to the Mac itself. So are DMGs, so disk image formats, right? That is native to it. So why would you pick one over the other? Well, we've been getting a lot of, requests lately is like, well, why is my DMG so large compared to a sparse image? We tell people to use the sparse image first, and then use a DMG if you have to. So we kind of recommend sparse image to be like, well, my forensics tools don't support sparse image. And then I tell you, well, do it the right way and buy RECON LAB. So it's not, we've heard all of it. And so it's hard. We're not just trying to push our tools and sell stuff. I mean, I would love you to buy our stuff, but for example, for as long as I've been in business, every tool that I ever had, if you're like law enforcement and you need it and you don't have a budget, we give it to you for free. So it's not about the money. I've proven that over the years. But the thing is, it's about doing it right way. And it's hard to keep telling people like, oh, let's help you work through this so you can put it into another tool and lose data. Like that's hard for me to do coming from forensic
Do
background.
all this hard work up front, and then when we get right up to the finish line, we're just gonna throw it out.
Exactly. So it's really hard. And I know people are saying like, well, our hands are tied. Well, then you got to change the hands that are tying you. You got to convince them not to tie your hands and explain, look, do you want just me to do my job and not care, or do you want me to do my job right and give you all the information that I can? Because if you're going to take it the proper way with the proper image that we can do with like RECON ITR, for example, but then put it into another tool that doesn't support those images and all the data that they contain, as if you would put it into RECON Lab, then you're not doing your job. So it's, you know, we'll be happy to give people demos too, like to get you through a case or something. So like, that's not an issue too. So, you know, we're easy to work with.
It's one of those things, it seems like you're just kind of working through it to get through this one case, but then if it comes and bites you in the rear a few months down the line, it's almost like, yeah, timestamps are a little funny looking, aren't they?
Yeah, so let's talk about that, right? So we keep saying Apple extended metadata. So if you're familiar with Spotlight, and we can do a whole nother section on this too, or you know, talk about it later, but if you're familiar with Apple Spotlight, Apple creates its own metadata so that you can utilize Spotlight within a tool. It's an indexing image, and it's totally different. It's totally unique to Mac. You have to be on the Mac to fully understand it and for it to recognize it. And there's things that the Mac does with Spotlight indices, let's say on different volumes, and that's what's mostly gets lost when you're kind of switching between different tools, or you know, people that, you know, other solutions try to reverse engineer that stuff and it doesn't come out right because it's not a Mac looking at itself, right? So then what happens then is there's ways to create those Spotlight indices during the imaging process that helps you preserve it. Part of that extended metadata is timestamps. The timestamps, this is the biggest problem I see with you know, people doing Mac forensics wrong, back to the title of this podcast, right? Is that every solution in the world shows the wrong timestamps in their interface. So the thing is like what you're looking at from every other solution in the world is POSIX timestamps, like Unix timestamps, because Mac's based on Unix, they can pull those out pretty simply. But the timestamps that are in extended metadata, the Apple extended metadata, those are the correct timestamps that you should be basing all of your opinions and analysis on, which you can't see in other solutions, or you don't collect properly if you're using different imaging stuff. This is scary.
And I mean, the stuff that we talked about earlier makes it even worse, right? So in the case that you do get a physical, which is becoming rarer and rarer, you're going to get the timestamps, but they're not the ones you really need to be looking at. So in most cases, you're going to get timestamps, but the wrong timestamps.
Exactly.
And then the wrong version of the wrong timestamps. So you're going to get the crummy logical ones that you got at the time of imaging. And then even if those were right, they're not what you should be looking at anyway.
Right. And see, that's what I think is where it's kind of sad in two ways. And I don't want to really, you know, I can't really make this nice, but nobody's really mentioning to you that you're looking at the wrong timestamps when you're analyzing a Mac with their solutions, and it's just nobody knows. Like, just nobody knows that you're looking at the wrong timestamps, except for the people that actually will take the time to listen to me at a lecture or class or when I'm drunk or whenever, right? You guys are using the wrong timestamps, you know, as I'm sitting on the corner somewhere preaching end of the world.
Can we do a drunk podcast next time?
Yeah, we can do it. Let's do it. Let's do it. But yeah, so it's scary. Think about it. Think of the implications. And we, on a serious note, we've dealt with other people and helped rescue them from cases going wrong, both law enforcement and corporate side, where the wrong timestamps were used in, you know, for rendering an opinion, whether it's a civil case or a criminal case. It's not good. And you don't want to be on that situation when people on the other side call you out on that and go, well, what told you is, well, do you realize that doesn't even show the proper timestamps? That's not good. That's not someplace you want to be. So we're doing our best to rescue the world.
Yeah, it's weirdly kind of a hard sell for a lot of people. I've had people kind of kick back and just be like, I don't, you know, I don't even try to, like, I don't care about that too much. And I'm just like, well, how do you not care about it? You have to care about it. Like this is going to come and bite you if you're not paying attention to it.
If the easiest way to put this is if your case involves timestamps and timestamps are important to you, then there are no other solutions right now other than to either use a Mac to do a Mac or use our tools and put it into RECON Lab and see everything properly. So that's one of the scary things. So going back to, while you're doing Mac forensics wrong, so the biggest issue, just to kind of summarize, I think, is one, you're going to need a password because data is encrypted at rest. You got to pass things through the secure enclave, whether it's a T2 or Apple Silicon. You have to be able to correctly image the Mac itself properly, where you preserve this extended attributes and the proper timestamps. So, we have that solution built into RECON ITR. And then going from there, let's say you do that part and you image it correctly, you fail again if you put this into any other solution other than, again, manually looking at this in the Mac with what we collect for you, or bring it into our solution, RECON Lab, which is designed to load those timestamps properly and see everything properly. And the timestamps, the Apple timestamps, the proper ones, are built into the interface itself. Right. And then, so those are some of the things. And then it's simple. Stay on the Mac ecosystem and you're fine. Go off the reservation. You're going to have issues.
There's no point in fighting against Mac OS. It feels like it's designed to not play nice with other operating systems. So why bother just going through the extra labor of trying to find out how to get it to work properly with a different operating system? Just work with it the way it wants to be worked with.
Yeah, well, it just makes sense, right? Mac understands Mac. Exactly. So it's the thing I've been saying forever. And the last thing that I want to talk about before we end this episode about, why are you doing Mac forensics wrong and all the excuses that we've ever heard about, like, it usually comes down to this. Once we got this far, and if you're still listening and haven't shut us down, right, so far, then it's like, well, I don't either see Macs enough or they're too expensive. And that, I just want to go ahead and dispel those things. So the biggest one is, our Mac's too expensive, right? I don't want to buy a Mac. I already spent too much money, this same thing. Well, first of all, if you're doing Mac forensics, you just need to. There's no option anymore. You have to do it. You're going to have to, and sometimes you're going to need another Mac to acquire another Mac, depending on what the situation is. And then the thing is, Macs are not that expensive anymore. The Mac Mini, as of this episode, right, the first one that came out with the Apple Silicon chip, is the #1 fastest Mac in the world for single processing, right? Single core processing. And for multi-core processing, it's the 13th fastest in the world. And it's $699.
I was gonna say, what's the thing around $600?
That's $699. So let me give you an example. We have bundles on our website, on our SUMURI website, that we're going to give you all the stuff you need to do Mac forensics and Windows forensics, essentially, right? You can do it all with lab and imaging and all stuff too. We give you 3 drives with ITR, which stands for Imaging, Triage, and Reporting. So we give you that solution to capture everything. RECON Lab allows you to analyze not only Macs, but Windows and every other thing in the world. And we can give you a Mac too for less than the price of anybody else's single forensics tool. So there's no more excuses to say, well, I just can't afford it. I can't do this. And if you really come to us and say, I'm a mom and pop shop, or we're law enforcement, we will work with you. Like, we'll give you the stuff you need to get you through what you need to. And when you get those big bucks in your hand, then you can think of us later and pay us back.
Exactly.
Yeah, it's pretty simple, easy to work with.
Or like bribe us with things, right? Send us cool stuff from where you're at.
We can do that too. We can,
I'll trade moonshine for software, right?
Yeah,
get something cool.
Sure, it's hard to find. That stuff you get in the liquor store doesn't really, it's not real stuff. Just saying. But yeah, so well, hopefully this was educational to you. Definitely, if you have any questions for us, reach out to us. We're just hello@sumuri.com or john@sumuri.com, and then you can definitely reach out to me. I've been out there for plenty of times. Notice I'm not mentioning my email address this time. You can do hello or john@sumuri.com.
Okay, just everyone can bother me.
Yeah, because my email doesn't follow normal conventions, so it's just gonna throw everybody off. But yeah, so stay tuned for more podcasts. We'll try to break some of these topics down and discuss them a little bit further, more detail, create some videos, pay attention to our YouTube channel. I'm hoping that we can still attend the conferences. Some go and some don't, so we'll be where we can be.
Yeah.
And hopefully see you. Yeah, see you in person. And again, if there's anything we can do for you, please reach out and follow us on social media. All right.
Thanks, everyone.
Yep, take care.